All right, in lesson 2, you remember when we did radians in pre-calc and we had this unit conversion. You also remember where we did some unit multipliers where the linear velocity equals the radius times the angular velocity, and we did several of these. So basically this is a unit multiplier. You have a wheel of radius 6 centimeters and it rolls down the hill at 400 RPMs, which is revolutions per minute, and they want to know how many yards per second. So the rest of it is just changing conversions. So let's look at centimeters. We need to go from centimeters to yards. Well, we know centimeters to inch, and then we have inches to yards, and then we have revolutions. Well, we don't want revolutions, so 1 revolution is 2 pi radians. And then we have the time. We have to go to seconds. Well, 1 minute is 60 seconds. And of course, they're not interested in these problems in the actual number as much as the unit conversions. And you're probably going to say, what happened to the radians? Well, there's 6 centimeters, which is the radius, is considered 1 radian. And so the radians just go away. Now there's also what we learned in pre-calc and algebra 2, the SOHCAHTOAs, which you've seen before. And then we have all the ratios for sine, cosine, tangent, as well as the reciprocals. And so these are all review from pre-calc. And then we have the 45-degree triangles. So you have the 1, 1, square root of 2, and then you have the 30, 60 triangle, which you should all remember from pre-calc, where it's 1, square root of 3, and 2. And so on these examples, what you're going to be doing is evaluating these using these special triangles. Okay, in example 2.2, we have sine squared pi over 3 minus tangent pi over 4 plus cosine pi over 6. So the first thing I did was I actually drew my triangles because those are all special triangles. So I have this triangle here, which is the 30-60 triangle, and I put in the ratio of the sides. And then I have a pi over 4, which is a 45-degree triangle, so I put 1, 1, square root of 2 for the 45-degree triangle. And now what we're looking at is finding what this expression equals. So I rewrote it, sine pi over 3. Now when you see this square up here, this is what it means. Sine pi over 3 times sine pi over 3. You cannot put it in your calculator this way at all. So if you ever put it in your calculator, it has to be written like this. However, since these are special triangles, we are not going to use a calculator on this. In calculus, you do have a no calculator part of your test. So now when I look at sine pi over 3, here's sine pi over 3, and opposite over hypotenuse, and I square it. Tangent is opposite over adjacent, and that's 1. And then if I look over here, the cosine of pi over 6 is square root of 3 over 2. So now I simplify, and this is what I get. Okay, now let's look at 2.4. We're going to evaluate 2 sine of 7 pi over 6 plus 3 sine of negative 4 pi over 3. Now before you look here, I'm going to look at 7 pi over 6. Remember, from here to here is 6 over 6 pi, or just pi, and then another 1/6. So that gives me a special triangle in the third quadrant. Opposite of pi over 6 is negative 1, negative because it's in the third quadrant. Adjacent is square root of 3, negative. And then the hypotenuse is always positive 2. So now when I look at that, that's 2, and the sine of this is negative 1 over 2. So that's what I've got there. And that simplifies to negative 1. Now let's look at this side. I have negative 4 pi over 3. The negative tells me I need to go clockwise. 1 1/3 pi. So now I'm in the second quadrant. And this is pi over 3, which is a 60 degrees. Opposite of that is square root of 3. Adjacent is negative 1, negative because the x in this quadrant is negative. And your hypotenuse is 2. So now it's going to be 3 times the sine of this, which is square root of 3 over 2. And then I simplify down to negative 1 plus 3/2 square root of 3. All right, now we're going to look at 2 pi, or 2.6. This is simplifying. What we have here is a trig expression, cosine squared theta, secant theta times tangent theta, and we have to simplify this. So if you recall, I can write cosine squared theta as cosine times cosine. Secant is 1 over cosine, and tangent is sine over cosine. That allows me to cancel this one with this one with this one, and I'm left with just sine theta. And now I've got it simplified. In example 2.7, we're going to simplify cotangent theta times cosine theta divided by cosecant theta. So it's always a good idea to change things to sines and cosines. So cotangent theta is cosine over sine. Cosecant theta is sine theta, because this is 1 over cosecant, so I get sine theta. Can't simplify cosine theta, so I left it alone. These two cancel, and so now what I have is cosine squared theta. Why do we want to simplify trig functions? Because sometimes in calculus it's easier to have a simplified trig function, and so we're reviewing that before we get into those later on. Now, I didn't do all the examples, but you should be able to have an idea of how Chapter 2 or Lesson 2 works.